Hi, it's Chris Kuzmal here. Today I'm going to implement the partition method, which is one of the classic operations in computer science that supports the quicksort method. Here I'm going to do this in a ab initio fashion, which is to say that although I know very much what the partition method does, I'm not prepared, as I usually am, to do this. And thus I expect to make a certain set of mistakes. And those mistakes are intended to be illustrative, to hopefully make it clear to students that even the simplest or most straightforward task is fraught with error and filled with mistakes, and this is going to be mine. So let's see how it goes. I will first create a REPL. And it's going to be a Java REPL, and it's going to be partition. And there it is. I hit create, and my window comes up, a number of options. And I'm going to go ahead and maximize the coding pane. And here I have main, in which I have hello world. The first thing I'm going to do is I'm going to write a stub of the method. And the first thing I do when I write a method is I write the name of it. So there's partition. The second thing I do, well, it's sort of an interesting choice of what I want to do. Do I want to give its return value? Do I want to specify its arguments? So yeah, those are the two basic questions. So I'm going to go ahead and specify the arguments first. And in Corman, Liserson, and Revest, in my edition, I think I have a second edition, on page 154, they have the partition method, and it calls for three arguments, A, P, and R. A, P, and R are an array and a pair of integers. And I'm torn here about whether or not to make it so that, let me zoom in a little bit on this code. I'm torn about whether or not to have A be an argument, or for me to modify, well, A would be an argument which would be an array which gets modified. That's the way Corman, Liserson, and Revest specify it. The other alternative is, well, there's two alternatives. One is I can make A be a field of the class that I'm implementing partition in, which could be main. And a third choice would be to still have A, P, and R, but where I would not necessarily modify A, but I would return A. For starters, I'm going to do it just the way that Corman, Liserson, and Revest have it. And so they put A, P, and R in their pseudocode. And of course, in Java, you can't have these three arguments be unspecified with respect to type. And I don't like having capitalization, so I'm modifying what Corman, Liserson, and Revest have by making A lowercase. And I'm going to go ahead and specify this input as being an array of integers. Another option here would be to make this an array of comparable values, but I am trying to keep things as simple, as basic, conceptually simple as possible, and or concrete, I guess would be the phrase, because while an array of comparables would be more general, it is also more abstract and would require further explanation for beginning students. P and R are both going to be integers, and I'm going to talk about what those mean very soon. But this is the specification for partition. It takes an array of integers A, an integer P, and an integer R. Now, of course, this does not complete the necessary syntax for partition to be invocable even as a stub. And that's what I'm going to do at first. I'm going to have partition be a stub. So that means a stub in general is a method with an empty body, although sometimes you have a return that's required inside of a stub. But because of the way that Corman, Liserson, and Revest define partition, we don't need partition to return anything. And this is convenient for creating a stub, because that just means that partition will be void. and the expectation is that A will be modified. And so when I specify the three things, look at this kind of annoying thing, it's not indenting consistently, I think, this indentation here. So I do three things when I specify my methods. I have an input, an array, and two integers. Okay. Output, none. And the third is, what's this little light bulb say? It's probably a suggestion. Generate toString? No, I don't want to generate toString. It's an interesting idea of generating toString, but no, I don't want to generate toString. Effect. Input, output, and effect are the three things that I like to put at the top as the documentation for any method that I write. The effect is a little bit involved. Modifies A so that every element in A in the range of P to R appears every element less than A of P in A in the range of P to R appears before to the left of every element greater than or equal to A of P. And now there's a little bit of a debate. I could have moved this. I could have this or equal here, or I could put the or equal. I could put less than or equal here. And which of those actually is appropriate? I will match the way Corman, Lysis, and Revest define things. I'm not 100% sure of. And the other ambiguity here is what exactly do we mean by the range of P to R? Does that mean that I can specify A of P? Does that mean that I can specify A of R? My inclination is gonna be that I can. My inclination is to believe that A of P is in the range of A to P to R, in the range of A to P through A to R, as does A of R. So that would mean inclusive. But I'm going to do some examples in order to really specify that fully out, and that will be in the test cases. Okay, and so the test cases are going to help me specify exactly what I'm supposed to do. Right now it's going to be incorrect, right? Because it doesn't modify A at all. Okay, and so that's the specification of partition, and at this point it should be possible for me to run this code, even though it's even though the stub does, well, it's a stub. So I go ahead and run just to see if there's any mistakes. There's no apparent mistakes. The code compiles and runs and prints out hello world. That's sort of the value of having hello world preserved in my main. So partition exists, and so now I need to create a sequence of test cases. And so I'm going to invoke partition test. All right, and we'll call it partition test 1. I'm tempted. Should I call it partition test 0? Partition test 1. And the intention of partition test 1 is to be extremely basic, okay? And but Okay, so let's go ahead and write that. This is the same overall kind of process. Writing the test is the same. I'm going to have partition test1 be void. Partition test1. It will take no arguments, and what it will do is it will create an array, int, open, close. I'm going to call it AR. And I'm going to have it be the empty array. There we go. And I'm going to have int p equal to 0, int r equal to 0. And so the question is, what's the proper behavior for partition for such an array? What if P and R are not in the arrange for array as I described a moment ago. Which is to say AR of 0 is not extant, doesn't exist. And therefore one would get an error if one attempted to access AR of P inside of partition or anywhere else. But we sort of think of it as being possible to access. So what to do here, I think that it's reasonable to define partition as being such that regardless of what the indices are, if AR's length is 0, we simply return AR. So I think that's reasonable, and it helps us because it makes it so that the partition method is correct as a stub. Okay, so we call partition of AR PR, and we expect there to just simply be no error. So how do we know whether or not things have worked out just fine? Well, if it succeeded in running without throwing an error. So so I immediately, despite trying to be simple, the thing is that simple test cases often expose complex behaviors, not necessarily extremely complex behaviors, but nevertheless behaviors that are not in the normal expected use case. And the normal expected use case is for there not to be an error. And so I'm a little bit queasy about attempting this, but attempting to handle this this case where it's going to be an actual error case. So I'm going to postpone. So we're going to go ahead and say, and actually I like naming this partition test 0 because we need to deal with a runtime error case possibility for this. And frankly, I guess in general, anytime we invoke partition, there's the possibility of there being a runtime error because of an index out of bounds issue or the indices P and R not being in bounds. So we don't do that check. We don't do that check at this time. Okay, so we'll worry about that greater level of complexity later on because I am trying to do a simple thing. So I am trying to do a simple thing at the same time as exposing the fact that even doing a simple thing has complexities. So it's perfectly reasonable to postpone dealing with complex cases. So I'm going to do a simpler case here. Partition test 1 is going to be identical to partition test 0 in terms of the code that we present in outline. So I copy and paste that. But I'm going to go ahead and have AR be of length 1, okay? And I'll put a 3 inside of it. Now AR of 0 is a legitimate is accessible without producing an error. And so when we would be done, I would expect AR to be unchanged. Well, in this case, that's hardly surprising. it's hard to do anything except for it to be the case. But for it to be unchanged, that is to say, I'm going to have expected, okay, be an array that I create, which is the array that I expect as a result, okay, and then if AR is the same and here, what am I going to do? What method? I need to write a method that compares two arrays. There may actually be a library call I can make. See, it's amazing how complexity appears even in simple situations. I believe there's probably an array library call that allows me to compare one array to another. But again, that's extra background knowledge that I would need beyond what a beginning student or very slightly beginning student would know. So I'm not going to try and invoke that or look that up. I'm going to simply do some comparison between AR and expected. Okay, and what am I going to do? I'm going to say if they're the same. If AR and expected are the same, then that means I pass the test, and I write pass plus plus. Otherwise, I write fail plus plus. Now, another complication. If I have a failure, I like to print something out. Really, what I like to do is record it in a log, but again, that's a complexity that a beginning student might not have, so I will go ahead and print this to the console. Error arrays expected, and then I've got to do some kind of thing that produces a string out of the array. So it's going to be two string, which is the classic toString for array, but toString is usually only defined for objects, and an array of integers is not. It's only kind of an object. And more particularly, I can't modify the toString method for the object of type array of integers, unlike for a class that I'm defining myself. So I'm going to have to create a method called toString that takes an array. And so expected, whatever toString, my toString method produces, actual is here, and toString of actual. Okay. Now then, the thing is toString. Oops, did I do this? toString is a method that I haven't defined, and I also have not defined same. Okay, so let's see what happens when I run. I expect to get errors. I expect a symbol not found. Cannot find symbol. PartitionTest1 also is improperly defined. Okay, I have void PartitionTest1, but this needs to be, cannot be referenced from a static context. Okay, sure enough. So the error, that PartitionTest1 needs to be static. Okay, so this is not, there's no object of type main that needs to exist in order for PartitionTest1, or for that matter, PartitionTest0 to exist. So it needs to be static. Should they be private? Yeah, they should be. In general, make things private. You can make them public later if you really need to. But sometimes it's difficult to go back from public back to private if someone becomes dependent upon your method that you made public. Now, the partition method itself also needs to be made static. Okay, because it was complaining about trying to invoke partition. So now let's run again, because that should get rid of one of the errors, and we get to have the cannot find symbol of same. This is the error you get when you've invoked a method. In this case, the method is called same, but the method has not been defined. And so that same method is right here on line 22. And I believe, I haven't looked any further, but I believe the method toString is also got a similar error, so we'll see about that. I've really written more code than I should have before doing a run to check things, because I have 2 undefined methods, but you know, sometimes you want to get things finished up. In principle, PartitionTest1 is good to go, except for defining same. So I'm going to have private static, but it's not void anymore, it's Boolean. Same, an array of integers, which I'll call A, and an array of integers that I'll call B. And our mission is simply to determine whether or not A and B are the same. So if A.length is not equal to B.length, then they're not the same. We're going to return false in that situation. Okay. Otherwise, and I'm going to go ahead and put else here. Well, we have a return. I like to do an else in order to very clearly distinguish that the that the code for each of the 2 branches of the conditional are exclusive. In other words, only one of them will run. Okay. Now, a return statement does make it so that you're done there. Nothing else is going to happen. And so I'm going to go ahead and just leave line 30 like that and not make an else, though. And instead, I'm going to go ahead and do a loop. And I would love to be able to do a loop for something along the lines of for int e in a. But the problem is I kind of want to simultaneously loop through each element in A and each element in B. Really, that's what I want to do. Really, I'd like to have some syntax in Java that's something like this: int f in B, and then say if E does not equal F, then return false. And then after that for loop, if we're still there, we're still around, we will finally return true. This is lovely, except for one little detail. Line 31 is not proper syntax for Java, and there is no syntax that produces the semantics of what I intend here. So what I have to do is I have to use the less abstract technique, and rather than that I'm going to implement by first saying int e equals a of I, int f equals b of I. Okay, that still hasn't solved my problem, and it's also complaining about probably other things. That is to say, this code still is not syntactically correct. So I've introduced another variable I, which is going to be my loop variable. So I is going to go from 0. I is going to proceed. This is the standard idiom for I less than a.length and I++. So the code on line 31 is the most common, I argue, I'm not actually certain, it's the most common, most idiomatic code in all of the C family of languages, in C, C++, and Java, and several other languages, I imagine. Line 31 would work. And it basically takes an index I and increments it from starting at 0 and going up to, but not including the length of the array A, making it so that it's valid to access A of I and B of I as well. And we can access A of I and B of I. Oops, I introduced a typo somehow just by clicking. I did some kind of interesting little accidental code trick. In any case, so line 32 and line 33 simply take A of I and B of I, which we can access successfully, we believe, on because line 30 guarantees that the lengths of A and B are the same. So we're pretty confident that line 32 and 33 will work, And now we can compare E to F, and so this same method should work. We're going to be lazy about determining whether or not same actually works. It'd be ideal for us to create test code to see whether or not same works, okay? I'm gonna skip that because I'm so determined to at least get partition test 1 to work for us before we reach the half-hour mark in our discussion. So see how slowly this is going. We're being very diligent about implementing partition, and we haven't even written a single line of code. We're testing the stub for partition. Okay, we're just setting up test code for stub and realized that we needed to write a whole other method called same that compares two arrays, and decided then that maybe we needed to write test code for same, and I'm skipping that because I am impatient. Okay, it's probably going to result in an error. Oh well, that's what I'm going to do. Now I also going to do the toString method. The toString method in this context, I got to be kind of careful here. It's kind of cool though. So this is going to be private. All right, string, and it's going to be static. If it wasn't static, then I would be potentially modifying the toString method that exists for all objects. I hope you're enjoying the drilling sounds in the background from the contractors. Goodness gracious. So, what should I do? Should I continue or should I stop? It's so loud, I've got to stop.